And now we begin Chapter 7. We're looking at 7.1 Part 1. It's a 3-part section. It's going to take us the entirety of the week. So Monday, Tuesday through Thursday, I believe, or through Friday. Okay, so let's get started. 7.1 Part 1. This is Tuesday and Wednesday stuff. We just looking at the angles in different polygons. Okay, so polygons in general are going to be just closed shapes, right? If you think of the shapes that you have, different sides, triangles, four-sided, squares, stuff like that, those are polygons. All right? So they're going to give us this sketch of a convex polygon, the number of sides, number of triangles formed, and the sum of the interior angles. So this is be kind of a little game here, if you will. So, in general, convex has a definition that is different depending on where you're at. The one that I learned was if I could put 2 points inside of the polygon, if I can put 2 points inside, and I can draw a line between them, that line never leaves that shape. Okay? So there's a couple of different ways to look at it. It's not going to be super important. Okay? An example of a non-convex polygon is a star, which I probably can't draw without doing this. But a star is non-convex because I can put a dot in these two and I draw a line, and that line would leave the shape. Okay, does that make sense? So, not super important here. But let's look at it. So, here's the goal. You're going to see the sum of interior angles correspond to how many triangles are actually formed when we're looking at the shape. If I zoom in like this, sweet. Okay. So for the triangle, it's 3 sides. It looks like this. We know what a triangle is. If you look at it, there's only one triangle formed. Okay. The sum of the interior angles is 180, right? Triangles are always 180. Okay. Now for a quadrilateral, here's the quadrilateral, right? This is actually the square. There are 4 sides to that. Okay. Now by number of triangles formed, what I'm going to do is I'm going to put my pen on one vertex. I'm going to draw a line to every other vertex. So these two already have lines, so I need to draw this one right here. Now we have 2 triangles formed. Okay? There's 180 degrees in each triangle, which means that there's going to be 360 total. If I look at those 2 shapes, there's going to be 360 total degrees. And you know that, right? Squares have 360 degrees. But if I look, 180 is in this triangle, 180 is in this triangle, and then you need all of them added up. Okay? That's going to be kind of the theme of doing the rest of these. Okay? Pentagon, that's 5-sided figure. Okay? There are 5 sides. Start at one side, so 1, 2, like this. So now we see we have 1, 2, 3 triangles formed. And so the sum of the interior angles is going to include all 3 of those triangles. So 3 times 180, I'm not going to butcher this in front of you, is 540 degrees on all of these, of course. Okay? See that plan? Hexagon, 6-sided shape. Draw the triangles. So 1, there's 1 there, there's 1 there, 1 there. So we have 1, 2, 3, 4. 4 triangles. To find the number, the interior angles, take 4 times 180, and you get 720 degrees. Okay? The drawings are getting worse. Heptagon. I learned the word septagon. Whatever you learned is fine. That's a 7-sided figure. Let's draw our triangles. There, 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 and there. Predictably, you have 1, 2, 3, 4, 5 triangles. So your sum would be 5 times 180, which is 900. Okay, we're really just going up by 180. Okay. Octagon, 8-sided, right? You've heard that in like wrestling, if you will. Draw the triangles. 1, 2, 3, 4, 5, 6. Take it times 180. I get 1080. Okay, degrees again. So in general, this is a pattern. You should have recognized it by now. It's been, what, 4 minutes? In general, if I have n sides, n could be 10, n could be 20, n could be 30, right? So this is an 8-sided polygon, 7, 6. Okay, so if there's n sides, notice how many triangles are formed. Okay, there are going to be n minus 2. So whatever we started with, minus 2, right? The 2 corresponds to, I didn't have to draw those first 2 triangles because it already had a line there, right? So if there's n sides, there are n minus 2 mini triangles formed. And to get the total sum of all of them, all we did was take 180, which is the size of one triangle, right, and multiply it by n minus 2. Okay? So to sum it up, if you have a polygon with however many sides you want, the sum of the measures is going to be 180 times n minus 2, where n is the number of sides. Okay? That's really easy, right? So now we're going to think about specific regular polygons. Okay? Now regular means that all sides and angles are congruent. Okay? Oops, sorry. All sides and angles are congruent. So for example, here's a square that is a regular, okay, I can't draw. That's a regular quadrilateral. Here's a rectangle, still a quadrilateral, but the sides aren't the same. So this one is not regular. Okay? That one is, assuming I can draw. Okay? So recall a regular polygon is both blank and blank, which means, so I'm going to put, let's see here. I don't know what they want for the words there. We're going to put, I mean, all the sides and angles. I don't know what the words they want there. So we're gonna go with what I said up here. Okay. Same sides, and it means the interiors of regular polygon are congruent. Okay. So the idea is all the angles inside are the same. So for example, not a good example here, but in a square it's 90 and a rectangle is 90. But in a triangle, for example, equilateral triangle, they're all 60. In a non-equilateral triangle, like here's a right triangle, now they're not all 60. Okay? So in a regular polygon, all the angles inside are the same and all the sides are the same. Okay? I'm curious what they wanted there. So let's finish this chart off. So for a triangle, okay, there are 3 sides, and as such, there are 3 angles. Okay? The sum of the measures of all the interior angles. Now we've talked about this. You take that 180 times n minus 2. So this is 180. This is just from the previous page, right? For the rest of them, I'm just going to copy. Remember, this is the formula right here. But I'm just going to copy them. Okay? So let's run that down quick. 4 sides, 4 angles, 360. 5 sides, 5 total angles, that was 540. 6 sides, 6 angles, 720. We skipped heptagon for some reason. 8 sides, 8 angles, that one was 1080. We'll come back to this. Okay? Now what it's saying is the measure of one interior angle on the right. Okay, remember these are regular. So that means that every single angle inside is the same. Okay? So to find one interior angle of a regular polygon, all you have to do is take the sum and then divide it by the number of sides, right? So to get, or the number of angles, excuse me. So what I would do to get the number, if we were looking at an equilateral triangle, like this, I would take the total, which is 180, and I'd divide it by how many angles there are, which is 3. So in this case, it'd be 180 divided by 3, which is 60, okay? In the next one, it'd be 360 divided by 4, which is 90, okay, and so on. So in the next one, pentagon, 540 divided by 5, each one is going to be 108 to make a perfect regular pentagon. Okay? For a hexagon, it's like a 120. Let's check. Yep, 120. And for an octagon, 1080 divided by 8 is 135. Okay? So in general, again, all I did was take this number right here divided by that number right here. In general, for n, there's n sides in an n-gon, right? N side of polygon. There are n angles as well. Okay. The sum of the measure from the last page was 180 times n minus 2. That's how you get all the angles inside of any kind of polygon, not just regular. And if you want to find one interior angle of a regular polygon, you take that number, 180 n minus 2, and you divide it by the number of angles. So divided by n. That's all there is to it. Okay. So to sum it up, that's the formula, 180 n minus 2 over n. You just take the measure of the interior of the full interior angle, the sum, divided by the number of angles. Okay? That's all there is to it for part 1. Good luck.